This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 9 of graphing cosine functions, and on this video we're going to graph y equals -2 cosine of x minus pi over 6 minus 3. Okay, let's write what we do know. In every single case, the domain for the cosine of the sine function is always just all real numbers. So we know that's going from -infinity to infinity. So that's something we know right off the bat. And then what about the amplitude? The amplitude is the absolute value of this coefficient, -2. So the amplitude is going to be 2. We have this -3 over at the end, so that's going to be our vertical shift. So since it's -3, that means we're going to go down 3 units. And then what about the phase shift? So if we set what's in the parentheses equal to 0, so we'll take the x minus, we'll figure this out. X minus pi over 6 equal to 0 means that if we solve for x, we get x equals pi over 6, which is plus pi over 6. That means everything is shifted pi over 6 units to the right, since it would be positive. So the phase shift will be pi over 6 units to the right. Now, this also tells us that is going to be our first key x coordinate. Okay? And how would we get the next x coordinate? Since we have a period of 2 pi, that means we'll add a fourth of the period. So we'll add pi over 2 to get the next key coordinate. So let's see if we could do that. So this will be the first one. The second x coordinate, we'd start with the pi over 6 and add pi over 2, right? That'll be a fourth of the way to the end of the period. And so I would need a common denominator. And this gives us 1 pi over 6 plus 3 pi over 6. That gives us 4 pi over 6. And I check these out and I see they have the same denominator, so that's great. So now we're going to go ahead and do a chart, and we know the first and second key x coordinates, and we'll fill in the rest of them. All right, so we're graphing y equals -2 cosine of x minus pi over 6 minus 3. Over here on the right, we have the regular values for just y equals cosine of x. And we're filling in our key coordinates. So the first one was pi over 6, and then we added pi over 2, which means we added 3 pi over 6, right? And that's how we got 4 pi over 6. So we'll add 3 pi over 6 again. That'll give us 7 pi over 6. Add 3 pi over 6 again. Basically, we're adding 3 pi to the numerator each time, right? And 13 pi over 6. Now, what about the y coordinates? So remember, we designed these, so if we put these values in, we'll get the, like if I put in pi over 6 for x, then the cosine, I'll be taking the cosine as 0, which means I'm going to have these y values over here. Oops, went down a little. So I've got -2 times that value minus 3 all the way through. See, it's -2 times something minus 3, -2 times whatever the cosine of what you get when you put in each of these values for x. So it's kind of nice to set these up, and then I could just fill in these y values over here. 1, 0, -1, 0, and 1, and simplify those. So I have -2 minus 3 is -5. 0 minus 3 is -3. 2 minus 3 is negative 1. 0 minus 3 is negative 3. And negative 2 minus 3 is negative 5. You should end up, right, where you ended up, where you started. It kind of goes negative 5, negative 3, negative 1, then back up, negative 3, negative 5, right? So it's very symmetrical here. So here are our key ordered pairs, and now we're ready to graph. All right, so how am I going to graph this? Well, I'm going to notice that my x-coordinates go from pi over 6 to 13 pi over 6. So they're all positive. You always want to write where your y-axis is going to be, but we're going to start, a little bit to the right of the y-axis, right? But then where should my x-axis go? If I look at my y-coordinates, they go between negative 1 and negative 5, kind of below the x-axis. So what I'm going to do is draw the x-axis kind of high and the y-axis a little bit to the left. And then remember, you look at the denominators. What's cool about having all the same denominator? That means if the denominator is 6, you want to make 6 markings till you get to pi, right? 1, 2, 3, 4, 5, 6. There's 6 pi over 6, right? 1, 2, 3, 4, 5, 6. That's going to be 12 pi over 6. Then you're going to have one more right here. And on the y-axis, I need to go down at least 5 spaces. So here's negative 5, for instance. So you want to label your x and y axes appropriately. Okay, so let's go for it. We've got pi over 6, negative 5. So we go over 1 pi over 6 down negative 5. That's our starting point. Notice it's going to start down because of this negative 2, and then it comes up, right? Oops, here we go. All right, so we have 4 pi over 6, negative 3. So 1, 2, 3, 4 pi over 6, and then we go down negative 3, about right here. Then we got 7 pi over 6, negative 1. So that's 4, 5, 6, 7. We're up here. So that's going to be our peak, right? Then we start going down over to 10 pi over 6. Down here. Gosh. Technical difficulties. I don't know why this is happening. Yeah, we got this, and then we've got 13 pi over 6. It's over there where we ended up. Okay. So the way it goes is basically it's going up. Then it starts curving to come down, kind of like a bell shape. And then you want to show what's going on afterwards. It starts going up again, right? Same thing over here. You want to show that it's starting to go up again. And there we have a rough sketch of our graph. Now, don't forget to give all the information about this graph, which we've written down before. The domain, remember, was negative infinity to infinity. And what about the range? The lowest point is negative 5. The highest point is negative 1. So between negative 5 and negative 1, always put the smaller number at the bottom. The period was 2 pi. Okay, the amplitude, that was the absolute value of negative 2, which was 2. All right, and what was the phase shift? I'm going to put phase shift was pi over 6 to the right. Right? And we also had a vertical shift because of this minus 3. Everything was brought down 3. So the vertical shift was down 3 units. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.